Okay, so let's get started. Right, so we created a repository, so let me open that repository. I believe we are working on a fresh repository, which we made a copy of the existing repository, right? Okay, so let's open that in offline mode. So remember when I'm opening in offline mode, so I'm not actually disturbing the repository that is currently being used for reporting. So which is our repository 57. So, and I made a copy of 57 and I'm working on sales repo 002, which is a copy of 57. So once my work is done on 002, then I may deploy it again. When I deploy it again, then it's going to create sales repo underscore 002 underscore BA 0058. Okay, so this will increment and this will create a copy, and that copy will be used. So you will see. So this is the repository that I was working on. So I simply open it, and the password of the repository is welcome one. Okay, so now what we did is we simply imported our physical structures, and again there was no relationship between the tables, and there's no keys and all, no. So which we managed to create an alias table. So now we have multiple alias tables here, including two alias tables for the time which we discussed, how does this alias table is going to help us. Okay, now, so I mean, like this, whatever the tables that we need doesn't matter, we can simply import these tables. And again, there is nothing you have to have only one source here. I mean, there's only one database here. You can have as many databases as you want here. You can import your structures from the Oracle database or any database, XML, normal files, Excel. So you can use a number of sources. So because the idea is, it should be able to fetch the data from the heterogeneous systems. So it could be any system. So at this point of time, we are doing the database. Probably, we can also check with the XML file and Excel if possible. But again, it's a straightforward. So the moment you import into the physical layer from the sources or from the structures, so that's it. I mean, the rest of the things is taken care by OBIEE. In the sense, suppose if you're importing it from an Excel sheet, so now you may think how come OBIEE be able to read Excel, and how come OBIEE will be able to join Excel to a database table. So how does it will really make these two objects as a data model and pull the data and relate them, right? So that's what we are paying for. So spending money in we are investing money in a tool. So the tool has the capability of doing those things. So it doesn't matter where your data comes from. The moment you input, they're just treated as structures, and OBIEE will take care of joining those structures as as a tables or as a relational model from the physical layer. Anyway, we'll see that. Okay, to start with, we'll start creating a business model. As I was saying, the business model in mapping there is a multi-dimensional structure. So what we are actually going to do in our BMM model is basically we are going to build a multi-dimensional model, where this multi-dimensional model will be used for the purpose of reporting. So as I told in the beginning, OBIEE is an OLAP tool. Since it is a OLAP tool, the basic functionality and the fundamental rule of any OLAP tool is this data should be in a multi-dimensional format. Now, so we are going to create the data in a multi-dimensional format. So this is a logical layer. So what is a logical layer? Basically, In a logical layer, it's only our assumption. There's nothing physically exist. What does it mean? Suppose say I may have tables here. Suppose if I say product table or if I say offices table. So this is a physical table, which means if I go to the database and if I take a look at it and I see a table with name SAMP underscore offices underscore D, that is my physical. So physical table exists in the database and it contains some data. Ajami, right? Now aliases are whatever the logical table BMM layer that we create, they are logical. It's kind of views on the tables. It's our own structures. So OBIEE is helping us to build our own structures on top of what we have. Right? Our own structures on top of what we have, and help us to pull the data in a faster way and efficient way. Right? So that is my model which I am building. So I have to demonstrate with the simple examples. As I was telling you the other day, I may have two tables where there is an EMP table. I may have EMP table, department table. So these are the, assuming that these are the physical tables. Probably now I may create something which is an EMP DPT. Right. So this EMP DPT is built based on my EMP and the DPT. This is the logical. Now, based on these two physical tables, I have built a logical here. So the advantage here is I can directly query on this table. Why am I query on this table? Why not on this too? Because logical it makes me easy because I've combined these two tables as a one single table. So my query will be easy. At the same time, I can build as many columns as I want, and I can build only the columns with the requirement. Suppose I may have 10 columns here. I may have 100 columns here. So probably together I may make a view with the 20 columns with the required information. That's it. So now I don't need to make a query to pull the data from here and pull the data from here and all the stuff. I don't need to. So I build a logical structure and I've simply start querying this logical structure. So here in between we have the OBIEE which takes care of converting this logical to the physical. So logical means say select star from EMP DPT. That is my logical. Because why am I calling it as logical? Why am I calling this select star from EMP DPT is logical? Because this table or this view EMP DPT doesn't exist anywhere. It's only part of OBIEE. It's nowhere exists. In the physical database, only these two tables exist. That's the reason I'm calling logical, which does not physically exist. But again, when I say logical, it is built on top of the existing physical table. So now when I actually make the query, I continue to work on this thing. I continue to work on this thing. I play around with this thing. Or I can create a number of things like this based on these two tables. My choice. But still, we'll be pulling the data from these tables only. So physically, these are the only two tables, but on this I can build as many logical structures or views I want. But end of the day, the data comes from these two tables only. So that's what we are trying to build. We are trying to build a business model for our requirement, for our reporting requirement. So far, this is just a physical data where we have it in a couple of tables, but the idea is, to convert the data from a normal traditional um, operational model to a data warehouse model that is one objective, because here we don't have a fact and dimensions concept, and we'll introduce the fact and dimension concept, and that way we can add OLAP features, multi-dimensional features here. At the same time, we can build our own logical structures with our own logical columns, with our own calculations. So the purpose of the BMM layer is simple: two things. One, you can build a multi-dimensional logical model. right? So the advantage of multidimensional logical model is, because OBIEE is an OLAP tool, if you have to provide that in a multidimensional model, so that OBIEE can utilize its OLAP features like hierarchies, drill downs, and all the stuff. Okay, the second thing, so that is the first thing. Second thing is, I may have a lot of data here. Suppose say in a sample revenue, I have revenue and the cost, revenue and the units. So this is my data. Probably I may need to create a lot of other calculations as well, or I may need to enhance my existing tables. Sorry, as for some, if you look at it here, offices, right? I may need to add few columns. I may need to get rid of few columns. So I will create a model where I'll create a subset of what I have here, and at the same time I'll enhance that subset to my requirement. So two things that we are going to achieve. One is multi-dimensional structure. Second thing is our own logical structures for the reporting requirement. So I may have only two measures here, like revenue and the unit. I may create 100 here, because imagine the requirement, we need to create the calculations. We need to use the calculations for the purpose of the reporting. Okay, let's get started. So, let's get started creating this multidimensional model. So right click, new business model. Now we'll be exploring on how do we create it manually. So simple thing is, you can drag and drop here. That makes sense. But at the same time, if you drag and drop, there are certain things that will automatically get created, and I want you guys to understand what is this automatic creation process, and in case if you need to create it manually, how do you do it? Okay, so I'm going to create a new model, which is a business model. I can give any name, model, as I can give model BI. So there is no restriction on the naming convention. You can give any name. Right, so now this is your model, and so my model usually consists of logical tables and the relationship between the logical tables, like something similar to here. So we'll also have the same thing, but again we'll have the logical models, and within the logical models you have the I can say logical tables. Within the logical tables you have the logical table sources, and within the logical tables you have the logical columns. Okay, then you build the relationship between the logical tables and all the stuff. That's as usual. So now I'm going to create a logical table to start with for products. Okay, so because I have already have a products physical table. Disabled means, like, at this point of time it is disabled. It's not actually used. So when your consistency is done, it is enabled. So it will become green. So I mean, when you're developing the repository, right? So you cannot deploy the repository halfway. Right? So you developed half of the repository without the proper relationship, which means before you deploy the repository, it should be consistent. So it should be enabled. So the process, the repository process, development process. Once you save it, it will ask you if it is a consistent. You will say if it is a consistent, then it will automatically enable the model. Otherwise, this model is not available for reporting when you deploy. Right. So there is a cross mark which is disabled now at this point of time. I cannot really use this model for the deployment. Even if I deploy it, my server will fail. Right, so I'm going to create a logical table, which is my products. It's a new logical table, products. Okay, this is my logical table. Okay, now, so what we are going to create? We are going to create one more thing, which is called logical table source. So this is an important aspect that you need to remember, the concept of logical table source. Sources means, for this logical table, I'm going to build a source. What does this mean? Right, so if I come back here, for this logical table, what is the sources? EMP and the DPT. So which means I'm going to create two sources here internally inside the OBIEE, which I call them as the logical table sources. So which means sources for the logical table. So this is one logical table source. This is another logical table source. Simple name. The name itself is logical table sources. So the sources for this logical table. So I'm going to create a logical table source here. Suppose say for this product, suppose if I want to build a product, so sometimes what happens is the naming may be a little confusing. So probably you may be thinking like why am I actually calling it as products? Yeah, that makes sense because I have used D1 products, right? So I may not be using D1 products here. So I'm creating my own name products. But again, is the products here and is the products here same? No. This is a total different structure that I'm building. This is one structure. But again, yeah, but when I'm building this structure, I cannot build a structure on my own without any mapping back to the some source. Say now, okay, simple. Suppose say I have EMP here, okay, I have DPT here. I'm building EMP DPT. So can I blindly build EMP DPT without EMP and DPT? No. If I build something without EMP and DPT, it is not going to help us in any way because I build EMP-DPT as a tool. It will simply allow me to create EMP-DPT. But if I don't have EMP and the DPT, when I make the query, if I already have a table to pull the data, it will pull. Otherwise, what happens? It says table EMP-DPT does not exist or table view does not exist. You'll get those errors, right? So when I'm building something logical here, EMP-DPT, I always need to make sure that there is some source available for me to pull the data. Otherwise, your repository is not going to work. So for every logical structure that you create in a multi-dimensional model or BMM layer, you need to refer it back to a physical source. In the sense, this table, where does this table get the data from, is the important factor here. Okay, right. So I'm gonna create my new logical table source. So before I'm creating logical table source, let me create a columns first. So let's not worry about the sources first. Okay, let's gonna create columns first. So I can create my own columns. So or I can also create the columns that based on this, because end of the day you'll be getting the data from this structure only, right? So probably we may get some of the columns of this. Say I say brand. But again, to make it simple, I'll say product brand. So to just make sure that we don't get confused between these two names. So now product brand is a total new column that does not exist here. I only have a brand here. But again, logical is my own creation. I can create my own table names, my own column names. The end of the day, they are different. Um, they they're not the same. This is different and this is different. But again, somehow we see that these two are linked. Where when I ask for some data here, and this has a source to go and get the data for. Okay, now I have my product brand. I'm going to create one more column, logical columns, right? Which in the logical table, I'm going to create my another column, which is my logical column. Say line of business. Okay, so I'm going to create my own column, line of business. Okay, there's another thing is a product type. I'm going to create one more. Okay, so I created three columns: product brand, line of business, product type. So let me create a primary key column as well, product key. Again, so I have just got rid of these underscores because I don't need. I mean, this is a logical column, right? I can create anything with my own name. So I have the column names, which is the column names that is available in my physical tables. See, end of the day, okay, these are also not physical tables. These are the logical tables based on our physical table. So if this is your actual physical tables, these are the alias tables, right? So the advantage of the alias tables is, if you have gone through the alias tables, if I double click on my alias table, so this is my alias table. If I go to the columns, I have the same columns available of whatever that I have in my physical. So another thing is, I cannot modify any of these columns. I cannot add a new column. I cannot delete the existing column. So it's same as physical table. So that's the advantage of the alias table. Only thing is, you can add your own key. That's what you need to remember. So I build an alias table on the physical table. So the column names are same as my physical table. So now I can, but when I am creating my logical model, I can create my own name. Now say, okay, I created my products and I have my D1 products here. But again, are these two different? Yes, they're entirely different. This is my kind of alias table, assuming that it has some data which is going to come from my physical table, assuming. So now, what is this? This is my logical table, which means it exists nowhere except in OBIEE. This table exists nowhere except in OBIEE. So now, if I'm talking about a brand, if I'm talking about a business line of business, if we're talking about product type and product key, this structure makes no sense when we don't know where exactly the data for these columns coming from. Right? Now, for that reason, what is that I'm going to do? I'm going to build my sources, which means, what is the source for these four columns? It could be one source or it could be two sources. Suppose say it could be one source where EMP DPT can be built on one source, or it could be from both the sources. It's our choice. A view can be built on a single table or a multiple table. Same here. My product table can be, my product logical table can be built from one product physical table or alias table, or multiple also. So if I am using, I could use like two tables, three tables, or even 10 tables. But again, I need to, in the logical table sources, I need to specify what is the source for this table. So where is this table, which means, where is the data for these columns is coming from. We are going to create something around logical table sources. So under the sources, I say a new logical table source, which means source for our logical table. So new logical table source. Now I'm going to create my logical table source name. I can give any name, LTS, logical table source, say products. Okay. So now map to these tables, which means I need to specify where is the corresponding table we are getting the data from the physical layer is something that I'm going to map. So what is that I'm going to map? So now out of all these tables, shall I use this alias table or the physical table? So we always use the alias table. So we can also use physical table, but again, what we decided, since we may need kind of the same table later point of time with a different name, so that's the reason what we decided we'll make use of alias tables for our business model creation, so that we'll have a flexibility tomorrow if I have to add something, or if I have to create a different combination. So kind of once you have the alias tables, so period, it's, you will be using the alias tables only. You will not be touching the physical tables. But end of the day, alias tables is also logical. So the data, I mean, OBIEE takes care of querying the same physical tables in the runtime. So when it actually queries, it will use the physical tables only, because nowhere we have the data except these tables. So, but again, what we are doing is a join. I mean, it's building a layer on top of another layer, just making sure we get what we need, right? So now out of all these tables, so you obviously now I need to get rid of. I don't really care about these physical tables, which starts with SAMP underscore. But again, what we are going to use, we are going to use our alias tables, which is D1, D2, D3, D4, right? So now for my product, which is logical table source products. So obviously my corresponding table will be what? Where am I going to get this data for this table? From the D1 product. So I need to choose my table D1 products. So this is my D1 products, which is an alias table, and I say select. So now I have selected my table, saying that okay, I'm going to get from the D1 product. So now if I go to my column mapping, if you look at here, so it's interesting. So what is interesting here? So now when I see here, my logical table products is having what? These many columns. So in the column mapping, I need to map these logical columns to some source, right? So under the sources, what we have now, we have defined one of the source, which is a logical table source. This is the products. Now I need to map the columns from D1 products from the BA sample to my products. So that's what my column mapping talks about. Okay, so since you have the source defined, which is D1 products, which is an alias table, so map the columns that is available in the source to the logical column that you have created, which is like these 4 columns. So if I look at here, what is my physical table? My physical table is D1 products. So in terms, when I say physical table, of course it's not actually physical, it's a it's again alias table, but as I mean, alias table is always built on the physical table only, so we can also call it as a physical table for our reference, though it is not. So what is our physical table? It is a D1 products, because alias tables use the same physical table columns except the key, so they are more or less physical tables only, but they are just created for the kind of what do you say, for convenience. Okay, now, so I have my logical table products. Okay, so if you look at the product brand, so now I need to assign my, see, there is a product brand, so I need to assign my product brand to the column that is available in my alias table. So what is my expression here? Which column that is available in my alias table for the product brand? A brand column. So now from the physical table or alias table D1 products, I have a brand column which I am mapping it to my product brand, which means I'll be pulling the data from here and I'll be assigning the data here. Okay, then I say I have D1 products and my line of business, it's LOB. Then I have my D1 products, I have my product type, this is my type. I have my D1 products and this is my product key. Right, so now simple, I did mapping. So see, the reason I need to do mapping is, if I build the logical columns, when I don't do any mapping, when I don't explain where actually the data for these logical columns is coming, it makes no sense, because I have my EMP DPT with the columns, but if I don't specify where is this EMP DPT coming from, like an EMP and DPT, then it makes no sense, because this is nothing. It's just a logical, you only kind of build some column names, which is a logical columns name. But again, unless you specify where this logical columns is actually getting the data from, here and here, then this makes no sense. This is just dummy. So now that is the reason for these columns I'm populating the mapping, so that when I ask for this brand, and we are telling it, okay, when I ask for product brand, you have to go to the physical, which is the D1 products, and within the physical D1 products there is a column called brand, and get the data from that particular column. That's what we are telling. Okay, so now it is going to create my logical table source. Now remember, logical table source is a source for your logical table. So technically it could be based on one single table, or it could be based on multiple tables also. But in our case, suppose, let's see an example. I have my products table, and I also have only one products table. Suppose, say, in a situation where you have more than one product table, then I can create one logical table source by adding one more physical table also, and I can join them and I can specify. So I can create my logical table source with a combination of more than one physical table also. Okay, suppose, say, for an example, if I want to create, I'll show you when we discuss the customer and the address. Okay, so we'll create the customer and the address now, then you'll understand. Okay, so this is my logical table products. So now I'm gonna create my customer, assuming, so I'm gonna create my new logical table. Okay, and I say customer. Now when I'm creating customer, let's create the logical table first. So I'm not really talking about any sources or anything. So inside my customer, what is that I have? I have some of the customer data. So I can give my own name. So when I'm creating a logical column, I always need to remember that I need to create my logical table. Sorry, I build my logical table in a way that that is more business friendly. So the column names and everything that I created, I need to see that they're making business sense. So I'm not actually going to create like any names like an underscore, sarcastic key, and keywords, and we don't do that because when we publish the same data, when we present the same data user, if I have these uh, kind of keywords or code names, business people don't understand. So we'll try to make as business friendly as possible and use the business names that is actually used by the reporting team or BI team, so that by looking at it they can understand, okay, this is what it is. Okay, so you don't need to really worry about what does this column means, what does this name means. So you technical guys, you can understand, but the business, they don't know. Okay, so we'll try to kind of give a business face to our data. Okay, so I say customer name is my column. So whereas in my customer, this is just a name. Okay, I can give that also if I want, but again, just customer name makes more sense. Okay, I'm gonna create one more column, which is type, or a customer type. That's um, customer name. I don't have any type in. So sometimes you're confused, like what to use, what to create. But in those situations, like what you can do, you can take a look at the data, because sometimes the column names may be a little confusing. But if you look at the data, it gives you an idea, what kind of data it is available. So I can right click and I say view data. But does this table D3 customer is having any physical data? No. But if I say, when I say view data, what happens? It will make a connection to the database and it will populate the data for few records and it will show it to you. So my repository will never have the data, but when I say view data, it will connect to the source tables and get the data and display the data to me. So now in my customer table, and I have this information. So I have a customer key and I have my income level, and I can say status. So this is the name that I have used, and right, I can say type key. This I can use type, which type of customer, and within the type I can say income level. Yeah, I mean there's not really a great data. Level 2. Okay, so what I can do is I can use only few columns. What are the columns that I think they make sense? I say name and type key and income level, status. Right. Okay, so probably now I'll use customer name, type, maybe income level, status. Okay, so I'm gonna create a customer name, and I can create a new thing which is called type. Okay, and status to understand if he's married or not. Income level. Okay, so now I created these 4 columns based on what I have, but I can say I may think my customer may have address, right? So if you look at my addresses table, so but do I have any address details here? No. If you look at my addresses table, if I see there is an address, perfect. Okay, but again, you need to understand one thing. My customer and address are related. Suppose if I select only these two tables, and if I actually join them, if I actually look at the physical diagram and selected objects only, so there is a relationship between these table exist based on what? Address key. So as long as I have this relationship to pull the data from this table, that is more than enough for me. Okay, now what is that I would like to do? In the same customer table, I want to also use the customer address and the city, because I want all my customer information to be in one place. Okay, so assuming, so what I want a city. Suppose say I want a country. That's it. Just to assuming, or address one, city, maybe country. So I can say new logical column, address. Okay, I'm gonna create new logical column, city, and create one more logical column, which is a new logical column, country. Right, so I created my logical table. But again, see, this logical table have the data coming from customer table and the address table. So now when I'm building my logical table source, what is my source for this? The source is two physical tables. One is your customer information, other is your address information. So now when I'm building the logical tables, I need to make sure that I have both the sources available as my logical table. So what is that I need to do? I need to build two logical table sources, one for customer, other for address. So I'm going to build a new logical table source, which is LTS underscore customer. Okay, so what is my physical table for the customer? D1 customer. Where is this D1 customer? Okay, D3 customer. Okay, that's one thing. Now, so into the columns of my customers, if I double click on my logical table customer, if I go to my column mapping, so address, city, country doesn't belong to the customer. So now but again, where is this customer? Customer name, type, city, customer name, type, income level, they belong to customer, right? So the D3 customer, this is the data, and the column that belongs to this is what? Customer name. And again from here I have D3 customer, which is my physical table, which is having a mapping back to the customer type. Again here D3 customer, I'm gonna mapping to the income level. Okay, so D3 customer, I'm having a mapping to what? Status. Okay, now I have mapping to these four columns, and these three columns I cannot map here because I don't have any relevant data in my customer table. So this is only for my, so I keep the columns empty without mapping. So now I create one more logical table source, LTS underscore address. So what is my physical table for that? My physical table for that is what? Address. Yeah. Okay, now if I go to my column mapping, see here, see it is some columns are auto mapped because the column name in my logical column and the column name in my physical addresses column name is the same. If the column name is the same, it will kind of do auto mapping. Okay, so it is got automatically mapped. But again, if the column is different from the column name that is available in the database, it doesn't map. Like for say address, I don't have address, I have address one. So if I define the column name as address one, it would have shown automatic mapping here. So that's the difference. But again, since we don't have same name, we have to map it manually. So address one, I'm mapping it to my address. So from here, country, I'm mapping it to my country name. Okay, now if you technically see here, these columns are not mapped here in logical table source. So now I have two logical table sources, one customer, other address. If I go to the customer, I do have the column mapping for the customer table. If I go to the address, I do have the column mapping for the address. So now this logical table is a combination of two physical tables. One is the customer and the address. So that is the beauty of OBIEE. Now, but when I do the reporting, it will take care of getting the data from here and getting the data from here and filling the logical structure with the data. So we don't really need to care about how it gets the data and how it joins these two tables. So that's something that is taken care by the OBIEE. I don't need to really have the relationship between these tables. My customer table may be independent table, my address table may be independent table. But you know what we do here? We actually use these two logical table sources. I build a logical structure based on these two tables. So this is one of the situation where I have these two tables. But again, what if these two tables is having a relationship? Suppose say if my customer and address is having a relationship, right? So they are not the independent tables. If they're independent tables, you can create two logical table structures, one for customer, one for address, because I cannot use the combination of these two tables as one single logical table source because I don't have a join. But in case if my customer and address are joined here, rather than building two logical table sources, let me get rid of these addresses. Okay, I mean this, so I can simply use my same logical table source customer, but again these columns are not mapped, right? So I can go to my general. What I can do is I can add one more table here. So what are the tables that I can add? I can add another table which has the relationship between the which has the relationship with the customer, direct relationship with the customer. So can you tell me what are the tables that is having direct relationship to the customer in my physical layer? If I go to my model, my customer is having a relationship to what? My customer is having a relationship to addresses. At the same time, my customer is having a relationship to revenue. So you can go to your model and suppose if you want to see like an addresses, suppose say customer, right click on the customer, physical diagram, objects and direct joins, which means for the customer, what are the direct joins available? See, customer, addresses, revenue. So now I can, if I want to see what are the tables my customer is joining to, which means this is this object and the direct joins to this object. So I'm having addresses and I'm having my revenue. So now when I say go to the customer, add another table, what it will show? It will show only those two tables because my customer can only be able to join those two tables. Okay, it's showing only those two tables because if I'm adding more than one table, there has to be a relationship between the existing table to the new table that I'm going to add. So now I'm having my customer, which is my existing table, which I have here. So whichever the table that I'm adding, so that should have the relationship exist. So now I can add my addresses now. So I have two tables. Now if you see here, there is a join difference with the customer and the address. It's an inner join. If I want to change the join type, depending on how you want to pull the data, you can also modify. Okay, so now if I go back to my column mapping, see some of the columns like in a city is mapped. So if I want to map my address, if I drop down, so now my drop down is showing what? My drop down is showing two tables. One is a customer and the address, and I can map it from the address. So this is actually used only when you have the relationship between the tables that is available in the physical level. If they don't have, I can still use my individual logical table sources to pull the data, and OBIEE will take care of connecting them. So that is the role of the logical table source. So logical table source is actually defines where exactly the data coming from. So I can define a very complex logical table, but again inside my logical table source I need to specify where is this data for this complex table is coming from. Is it from one table, two tables, or 10 tables, and which column from my logical table is mapping back to which column to my physical table is something that I need to look at it. Then only I'll be able to pull the data into this logical table that I've created. Okay, so that's how you create your customers with a single logical table by using more than one physical tables. Here I have created a logical table with single physical table. So here I am using two physical tables to create my logical table. Okay, now so I have my customer ready where I also see the mapping with the customer. So similarly, I can build my time, or I can build my offices. So I can build one more logical table, offices. And again, I'll build my logical table first, and I can build my logical column. So in my offices, what do I would like to use? Suppose sometimes, if it is confusing to you, and I can go here and I can see some of the columns: company, department, organization. So I'm going to use these three only. And I see you may be thinking like, how can you directly pick this data? Because I know it. So if you want to know what is the data that you want to pick, you can go to your offices and right click and view data and look at the data and see that what data makes sense. I'm going to pick up my company, I'm going to pick up my department, where I'm going to pick up my uh, probably organization. What type of organization? Probably I can also pick up my office description as well. Okay, there's 4 columns. Or if the is confusing, then you can only select those columns and organization. Then you can look at the data for only 4 columns, so only the required data is available. So company, department, organization, description. So I'm gonna create a new column, company. I can say department. This column name can be your own name, but again, so we are going with the same department standard naming convention. Description. Office description. And I can say organization. Okay, now this is my logical columns which I different. So, but again, need to remember one thing: there should be a key column. Otherwise, your model will fail. So probably I can create a key column which is a customer key. Map it back to my customer. I'm mapping it to. Okay, so one key column is sufficient. I don't need to go for both the key columns. So here, offices. Do I have a prod key? Yeah, I have a prod key. So in the offices, I would like to use my office key. Okay, so now I'm gonna build my logical table source, new logical table source for the offices, and I can give the name LTS underscore offices. Okay, I'm gonna go to my column mapping where I would like to map my logical columns to the physical columns. So I say from the company, what is my physical table? My physical table, I don't see any physical table yet. Okay, didn't I add? Okay, I have not added it. I just gave the logical. So LTS offices, I need to add my table. What is the table? Offices. D2 offices is my table. I select my D2 offices. Now if I go to the column mapping, some of the columns are automatically mapped by the column names that I have given for the logical column, and the column names that is available in the physical tables are same. If the column names are same, then it will do auto mapping. If the column names are different, it will let you do. Suppose the office description it did not map because the column name in my physical table is office underscore DSC, but the logical I have created as the office description. Okay, so I have my D2 office, and the column that I'm mapping is what? Office description. Okay, then for the office key, I need to choose my offices, and I say office key. Right, this is my column mapping which I have done. So I have done my mapping to my offices. Okay, so now we have done the mapping for my customer, office, and the products. So this is the offices table. We have the logical table source LTS offices, and if I look at the mapping, I did the mapping from my logical column to my physical column. This is the column mapping. Okay. Similarly, I can create as many logical tables as I want based on my physical table. So probably I can also create one more products also with some of the columns from the product. So I can. So, but again, we always consolidate rather than normalize. So, which means we always try to create one product table based on the multiple product tables. We don't really create, it's like I have created a customer based on the customer and the address. That's how that's the way we build our multi-dimensional models. We don't really normalize it. We'll try to denormalize. In the sense, we'll try to make it one single table from more tables than splitting one table into multiple tables. Okay, so that's what my the fundamental concept of the multi-dimensional model, where we build the fact and dimensions, which is in a consolidated form. It's a kind of a combination of data. So we always create logical sources from multiple physical sources. Okay, now I have my customer offices products. I may would like to build a table revenue. Okay, so within my revenue, this is my again, I would like to know what columns that I would like to use the revenue. So probably I may want to use two columns, which is revenue and units. So I can say new logical column, revenue, and I'm going to build one more logical column, units. Now, what is my logical table source? My logical table source is, I can say LTS underscore revenue. Okay, so what is my physical column, which is again revenue here, which is my F1 revenue. So if I go to the column mapping, so this is the mapping automatically done. Why? Column names are same. That is it. That is the reason. Otherwise, it won't map. So I did my mapping. Okay, so now if I look at here, so all these tables are logical tables. So if you look at, so all the tables are kind of having what hash. In the sense, they are they have they're treated as a fact tables, because the table with hash, right? This hashtag inside it, that is a fact table, which is assuming the table with the number. So by default, every table treated as a fact table. But to define, so creating logical tables are fine, because I can build my own structures and I'm building everything. But again, I need to define as a business model, right? It's not something, no, I'm just creating logical tables, doing mapping, getting the data. So as a business model, suppose say my customer is a table which is created based on my customer and the address, or maybe created based on the 10 tables. So I'm building a total new logical structure of my own choice. So end of the day, once we create this one, we probably don't bother about our physical, because I already built my logical. So when I'm building the logical, I have to keep something in mind, how these logical tables are also related. So I'm building a total new table, right? But this total new table also, I need to see how these logical tables that we have created are related to each other. So that's where I need to define my business model relationship. I need to specify how my logical model mapping looks like. So I can say right click on my model, business model diagram, whole diagram. In the sense, I would like to see the tables that is available in my logical model. So if you look at here, there is no relationship because I have defined my tables, just new tables. So I don't have any relationship exist. Suppose if I want to build my time, I can also build time. So to save the time, I'm gonna directly drag my time here. So, but again, see, you see a difference, right? Why? There is a time. The time is not actually being shown as fact table. It is shown as a dimension table. So if I say right click, business model diagram, whole diagram. See, my time is linked to my revenue. Why? Because there is a relationship between the time and the revenue in the physical table. Since you dragged and dropped it, it is automatically identifying it. So that's how it looks like. So let's not drag and drop. But again, even if you drag and drop, doesn't matter. So yeah, I'll keep this way. Right, so I'm gonna rename this D4. So there's multiple ways of doing it. That's what I'm trying to show you. You can drag and drop also, or you can create them manually like you created here. Okay, and you can also keep the columns that is required and get rid of the columns that is not required. So that is a hell of a challenge. Here, I can say I'm gonna get rid of all this unnecessary data. I'll tell you why. So I don't need them, and all I need is these 6 columns, which I have at this point of time. Apart from that, I may keep some fiscal data also. So make sure that you keep the primary key data. You don't remove this primary column. So I'm gonna remove the rest of the columns. So this one, I'm gonna remove them. Okay, so I have together 5-6 columns available, but again these column names are weird. See, remember when you drag and drop, logical table source is automatically created. The source is D4 times, so it is automatically created because you drag and drop, it creates everything automatically. Which means when you drag and drop, it creates a table, logical table, and it creates a logical table source. It simply uses the same logical columns, and it also automatically, if I go double click, and so there is a mapping defined. So everything is set when you create a logical, when you drag and drop, because it creates everything. But again, why am I doing manually? See, it gives us an idea like how it is actually being done. That's the reason I've shown it to you. So now for the time, if I would like to say rename wizard, because I have the columns, weird column names, so I would like to get rid of those column names. So all text lowercase is one, and remove occurrence of underscore into space. First letter of each word is a capital. So next, okay, only using these 2 columns. Okay, so now let me use on the columns. I think it's not taking the table. Rename wizard. All text lowercase into space. First letter of each word is capital. This is standard. See, now it is using this 5 column. Okay, now I got the column. So now this is a one way. So I can also rename. If I want to manually rename, I can also manually rename. So I have the liberty to choose anything. So if I want to rename this guy D4 time, so I can also rename LTS underscore time. So any naming convention that I want. So perfect. So now if I go to my model, business model diagram, whole diagram. So if I see all these tables that I have no relationship except my revenue and the time, because I already have a relationship between the revenue and the time. Since I dragged my time to BMM layer, it is automatically identified to which table it is linked. So time is always linked in to my revenue in the physical, right? The same relationship, it is reflected here. Okay. So again, the relationships actually doesn't change. We would like to use the same relationship. Even in the business model also, they are related the same way. I'm going to define my join between these logical tables, revenue to my products, which I'm trying to analyze my revenue with respect to my products. Let's say one to many. Revenue to my customer, same. Revenue to my offices, same. So I build a relationship of my own. So there is no hard and fast rule, like you have to build the relationship only this way. But again, yes, you need to understand the business. From the business only, you need to define. So in the sense, I have my revenue where I would like to analyze my revenue from the different perspectives. What are the different perspectives here? So I am analyzing my revenue from the customer perspective, and analyzing the revenue from time perspective, analyzing the revenue from offices perspective, analyzing the revenue from products perspective. Okay, so only column that I have is, see, now you see, only column I have here with the hash is revenue. Why? because revenue is the fact table. So why am I calling it as a fact table? Because if I look at here in a multi-dimensional model, any table linking here, this looks a fact table. So in the sense, in a star schema, this is a star schema. So in a one-to-many relationship, the table that is on the many side is always a fact table. So if I double click here, what is the relationship? My revenue is on the many side, n side, and my time is on the one side. So one to many. So for all these tables, my revenue is on the many side. That is the reason my revenue is treated as a fact table, and the rest of the tables are treated as a dimension tables. So now I have my revenue and my columns like in a revenue and the units. If I double click on revenue, I can set my aggregation to sum or average. Why am I setting my aggregation? Because when I use these columns, what do you say? When I use these um, logical columns, when I use these calculations, right? So reports are always aggregation. Report first, what it does, it is try to aggregate and display the data in a summary form. It doesn't display the data of thousands and hundreds of rows. So now somehow my data has to be always grouped. So what OBIEE does is whatever the columns that you select, based on the columns, it will group by kind of first column, and it will try to summarize the data and display the data to you. So when it is trying to summarize the data has to be summarized on multiple things, like it could be a sum, or it could be average, or it could be minimum, max. So that is something that we are specifying the aggregation, the revenue. So the default aggregation is sum that I have defined now. So that way, without saying, if I use revenue with any combination group, what happens? It will summarize. It will kind of sum it up and it will show it to you. That's what the default aggregation means. Okay. Now similarly, we don't have much to do in our presentation layer. I can create a new subject area. Subject area is like kind of business name that we are giving. Suppose I can say create a subject area, sales north. That's my own choice of name. Okay, so in my subject area, I can create a new presentation table, say products, and here new presentation table column. So whatever that I'm defining there, right, I can define. So I can give my own column name. Okay, use logical column name. If I want to like to use my logical column name, I can use. Um, so I can browse my logical column name. Say products. From the products, I'm gonna choose my product name. Product brand. Hmm. Okay, I don't think there's a product name, right? There's a product brand type. I have like these things. So that's the reason you have to have the column names properly defined. Say now, if I say use the logical column name, and it will automatically use the same name that I have mapped, right? So I've added one column. Like that, I can keep adding as many columns as I want, but I cannot define my own columns here because it makes no sense. I cannot define my own column name because this column does not exist without this. So all the kind of modeling done here, only presentation part, how do we use and what combination and all, we can define it. So that's the one way. Or if you think like that's unnecessary, you can get rid of this guy and you can simply drag the products here. And the office is here. This is one combination I'm specifying in my north. I can say new subject area, sales south. And again, if I think like time and the revenue and the products is a combination that I would like to use, I can use like that, and I can create as many subject areas as I want. So that's how so one model is being presented differently to the different set of business users, which we call them as a subject areas, different business subject areas. Now, when everything is done, I need to define the keys at this table level. So otherwise, it will say that there is no key exists. I define the key for products, I define the key for offices, and I'll define the key for customer. I think I have the key for time because I dragged and dropped the table. The key automatically got created. Okay. So now my model is ready. I would like to say save. So do you wish to check global consistency? Yes. Okay, it's perfect, consistent. So which means no, it's good. I mean, it couldn't find any issues. Say yes. So it will mark it available for queries. If I double click on this one now, I don't see it as disabled. Why? Because it's not disabled, it is active. So it has changed it to it is got automatically unchecked because the repository is created without any uh, errors or any issues that is the server should bother about. Okay, so like that we can build a repository on our own with our own kind of logical columns, mappings, and everything that we can do automatically based on our requirements. That is a core fundamental concept of creating repository manually. So tomorrow we'll explore creating kind of actual multi-dimensional model. What is a multi-dimensional model? What are hierarchies? We'll discuss more on how do we take this to the next level of creating hierarchies and what do we do about it. Okay. So any questions or anything before we wrap it up?